Yes, in the today's session, we are going to discuss frequency sampling structure for FIR system. Nothing but we are sampling the frequency components by selected values. So the FIR system is realized only at frequencies of interest. I mean to say that we are going to sample nothing but dividing the frequency values for selected values. So omega indicates indicates frequency, and we are going to sample by using selected values as of our interest. Because of this reason, reduces the complexity of the system. See, let us assume where omega indicates the frequency component that is sampled by m samples, where is the k is the interval. The value of k varies from k equal to 0, 1, 2, 3 up to where m minus 1. So it becomes here omega is the frequency at discrete points of interest. Then we are going to calculate unit sample response of the FIR system, that is represented as h of n. H of n, where h of n indicates unit sample response or unit impulse response of the FIR filter. Then let us take the Fourier transform of h of n, that is represented as h of omega. So as per the definition of, with the help of definition of Fourier transform, by using the definition of Fourier transform, I am going to calculate ft, Fourier transform for h of n. Hence it becomes h of omega equal to summation over the limits n equal to 0 to m minus 1 h of n multiplied by e to the power minus j w n. That is represented as equation number 1. As already we discussed, we are going to sample for the discrete points selected frequency components. Hence omega is written as omega k. So it becomes h of omega k. H of omega k equal to the same equation. Above equation I'm going to rewrite as uh, omega k equal to what? 2 pi by m into k is there. So wherever omega is there, that is replaced by 2 pi by m into k. That is equal to summation over the limits n equal to 0 to m minus 1 h of n. This omega is replaced by 2 pi by m into k into n as it is. Okay. Now in shorthand, the this term is represented as notation called as k. There is no change in the meaning. Simple, it is the shorthand notation representation of what? The above term. Hence the above equation we are going to rewrite as h of k equal to summation or the limits n equal to 0 to m minus 1 h of n multiplied by e to the power j 2 pi by m into kn, where the value of k varies from 0 to m minus 1. Hence represent it as a equation number 2. So if you compare this term, this equation number 2, if you compare with the definition of DFT stands for discrete Fourier transform. Both are looks same. It is nothing but it looks like a definition of discrete time, not discrete time, discrete Fourier transform. Definition of DFT. So the length of DFT is what? There are m samples are there. Length of DFT is m point DFT. Hence the above equation represents m point DFT of what? H of n. In the first, okay. After that, let us calculate inverse DFT. Inverse DFT for the h of k, that is represented as h of n. H of n equal to 1 by m summation over the limits k equal to 0 to m minus 1 h of k e to the power j 2 pi by m into k into n, where the value of n, where the value of index n varies from n equal to 0 to m minus 1. Here in the above equation, DFT equation, it is m point DFT equation, where the index k varies from 0 to m minus 1. In inverse DFT, the index n varies from 0 to m minus 1. Let us represent as a equation number 3. Next, we are going to calculate, apply Z transform for the h of n. Let us calculate Z transform. Then equation becomes h of z equal to summation over the limits n equal to 0 to m minus 1 h of n multiplied by z to the power minus 1. Let us represent as equation number 4. This is nothing but, this equation tells us that it is the z transform of h of n. Now substitute equation 3 in the previous equation, that is inverse. Already we calculated h of n, that is we calculate h of n. How we calculated? We calculate h of n by taking the inverse dft. So that equation substitute in the equation number 4, then we got h of z equal to summation over the limits n equal to 0 to m minus 1, h of n equal to, in the previous equation, that is in equation number 3 we got, that one I am going to substitute here, 1 by m summation over the limits k equal to 0 to m minus 1 h of k multiplied by e to the power j 2 pi k by m into kn multiplied by, as it is, z to the power minus n. Let us simplify this equation, rearrange the terms. Here observe, two summation terms are there. One summation term having the index n and other summation term having the index k. Rearrange the summation terms in such a way that there should be match of indexes. So how to rearrange or how to interchange the order of summations? See here, k is there, here k is there. Okay. So because of that reason, I will take this summation term outside. So because of that reason, h of z equal to summation k equal to 0 to m minus 1, h of k as it is I have taken outside, 1 by m outside. Left with what? Summation n equal to 0 to m minus 1, then e to the power j 2 pi by m into kn multiplied by z to the power minus n. And one more simplification in these two parameters, in these two terms, observe the power term n is there, here also power term n is there. Let us take from these two terms, let us take n as a common, power term n as a common, then it becomes e to the power j 2 pi by k multiplied by j to the power minus 1 whole raised to n. So from these two terms I have taken the power term n common, this becomes like this. So what we did here, we rearranged the, interchange the order of summation terms, then we got this equation. Let us observe the terms which are present inside the square bracket. By seeing this equation, the term which is present inside the square bracket, we can say that it it is similar to one geometric series formula. What is that? Summation n equal to 0 to n minus 1 a to the power n. That one we are going to write it as 1 minus a to the power n divided by 1 minus a. Okay. Let do comparison of these two equations, the term which is present inside the square bracket and this equation. Here summation term is there, 0 to n minus 1, 0 to n minus 1, and which is present in the flower bracket, in this bracket, it acts like a. I am going to represent as a. The term which is present inside the bracket, I am going to represent as a. Hence a equal to what? A equal to e to the power j 2 pi by m k multiplied by z to the power minus 1. So using this formula, what is that? 1 minus a to the power n, 1 minus the remaining term as it is, I am keeping as it is. Next, 1 minus a is what? E to the power j 2 pi by k by m into z to the power minus 1. Power term is what? A to the power n is there when limits are n minus 1, 0 to n minus 1. Here in this case limits are m minus 1 is there. So because of that reason, power term is m. And coming to the denominator, 1 minus a. 1 minus a term is what? E to the power j 2 pi by m into k multiplied by z to the power minus 1. Next, for the simplification, m e to the power j 2 pi by k, e to the power j 2 pi by m into k, this term, power term multiplied by m get cancels, left with what? E to the power j 2 pi k, and this one z to the power minus m as it is. Next, for the simplification, we know that e to the power j 2 pi by 2 pi k, that one we are going to write it as cos of 2 pi k plus j sine of 2 pi k. Cos of even multiple of k, k may be any value, k may be 0, 1, 2, 3. Substitute k equal to 0, we will get cos of 0. Cos of 0 is 1. If you substitute k equal to 1, cos of 2 pi. Cos of 2 pi is 1. If you substitute k equal to 2, cos of 4 pi. Cos of 4 pi is also 1. Hence, any value you can take for k, you are getting what? Cos of even multiple of pi. Cos of even multiple of pi always results in 1. So it results in 1. Next, second term, sine of 2 pi k. Sine of 2 pi k is 0. Hence, the overall result is 1. Simplifying e to the power j 2 pi k, this term results in 1. Hence, substitute here h of z equal to this term as it is 1 by m summation k equal to 0 to m minus 1 h of k 1 minus this term becomes what? This term becomes 1. Hence 1 minus only left with what? Z to the power minus m divided by 1 minus e to the power j 2 pi k by m multiplied by z to the power minus 1. Okay. Rearrange the terms. Same thing. The equation I'm rearranging in the order. H of z equal to 1 by this one. 1 minus z to the power minus m because term m is there, m is there. So rearranging 1 minus z to the power minus m divided by m summation or limits k equal to 0 to m minus 1 h of k. Here also k is there. H of k divided by 1 minus e to the power j 2 pi k divided by m into z to the power minus 1. Let us represent it as a equation number 6. Now I'm going to split this h of z into two subsystem functions as h1 of z and h2 of z. Those two are arranged in cascade or in series format. Product of these two subsystem functions. First, what I did here, I divided the system function h of z or transfer function h of z into two subsystem functions h1 of z and h2 of z in series format, in cascade format, or product of two subsystem functions. Next, what is h1 of z? H1 of z I'm going to indicate as a, this is as a h1 of z. This one I'm going to represent as a h1 of z, and the term this one I'm going to represent it as a h2 of z. Okay. See, next step. Now, so h1 of z equal to what? 1 minus z to the power minus m divided by m, and h2 of z equal to what? Summation over the limits k equal to 0 to m minus 1 h of k divided by 1 minus e to the power j 2 pi k divided by m multiplied by z to the power minus 1. So now realize, now sketch the structures for h1 of z and h2 of z. First I am going to sketch, both are in series connection. First I am going to sketch h1 of z. H1 of z is what? See, before that I am going to simplify here. H1 of z equal to 1 minus z to the power minus m is there divided by m. Okay, this one I am going to simplify as h1 of z equal to 1 minus z to the power minus m divided by m. Okay, further simplification. So it is the ratio of output by input, y of z by x of z. Okay, it is 1 by m, it is common, 1 minus z to the power minus m. Next, class multiply y of z equal to 1 by m as it is 1 minus z to the power minus m into x of z. Hence, y of z equal to 1 by m as it is x of z minus z to the power minus m into x of z. So next, let us take inverse z transform. Let us take inverse z transform. What we are getting, y of n equal to 1 by m as it is. This becomes inverse z t x of n minus divided by what? How many times? M times x of n minus m. Okay. Is it clear? X of n, coefficient term is 1. X of n is divided by m times, coefficient term is 1. And the overall term is multiplied by 1 by m. So the same thing I'm going to sketch here. This is the relation of h1 object. X of n equal to first, this is 1 by m, take it outside, multiplication 1 by m. Otherwise, next, divided by how many? Divided by m time, because of that reason z to the power minus m, and add with the previous operation, it is plus. Then go to relation of h2 object. H2 object equal to summation over the limits k equal to 0 to m minus 1 h of k divided by 1 minus j to the power 2 pi k by m multiplied by j to the power minus 1. See here, if I substitute k equal to 0, if I substitute k equal to 0, the term becomes h of 0 divided by 1 minus e to the power 0. E to the power 0 is always 1. E to the power 0 is e to the power 0 is 1. So 1 multiplied by z to the power minus 1. Hence this term becomes h of 0 divided, when k equal to 0, it becomes h of 0 divided by 1 minus z to the power minus 1. So first relation, it is a pole term. The term is present at the denominator, it indicates poles. So arrow mark is left side. What is that? First 1 minus 1 time delay z to the power minus 1. Coefficient term is what? Coefficient term is 1 is there. We have to take opposite symbol of, while realizing the poles, we have to take the opposite symbol. Here minus is there, because of that reason the coefficient becomes plus 1, and adding with the previous result, and this is multiplied by what? H of 0. The overall relation is multiplied by what? H of 0. Next, go for k equal to 1. If I go for k equal to 1, h of 1, wherever k is the substitute 1, h of 1, then 1 minus e to the power j 2 pi, this is 1, 2 pi divided by m multiplied by z to the power minus 1. Same thing here, relation of second k equal to 1 divided by 1 time z to the power minus 1 is there, multiplied by the coefficient what? E to the power j 2 pi by m, and take the opposite sign because it is a pole term. So this will become the k equal to 1 multiplied by what? H of 1. Similar goes on, substitute k equal to 2, k equal to 3, k equal to 4, up to where? K equal to m. All are in parallel connections. H of 0, H of 1, all are what? K equal to 0 to k equal to m minus 1, all are in parallel connections. Next, up to where? K equal to m minus 1. So the last term is what? K equal to m minus 1. See here, if k equal to m minus 1, what happens? Z to the power minus 1 as it is. Wherever k is there, substitute m minus 1, e to the power j 2 pi m minus 1 divided by m, and all are in parallel connections. And h1 of z and h2 of z in product of sub functions, subsystem functions. Hence, it becomes what? Cascade connection. The output of first h1 of z, the output of h1 of z is given as the input for the h2 of z. This is the relation of h1 of z, and this is the realization of what? H2 object. This is about uh, sampling, frequency sampling of FIR systems. We will take one example, and you will get the clear idea how to sample the frequency of FIR systems. Let us take one example. Determine the transfer function h of z of an FIR filter to implement h of n equal to delta of n plus 2 into delta of n minus 1 plus delta of n minus 2. Okay. Now, using the frequency sampling technique, how to realize using frequency sampling technique? Already we discussed theoretical concept. Let us make use of that theoretical concept, and we will solve this example. First step number 1, obtain transfer function. See, observe the coefficients of these three terms. There are h of n contains three terms, hence the length of filter is what? m indicated by m, that is 3, m equal to 3. And coefficients observed here, delta of n is what? 1. Hence h of 0 equal to 1. Coefficient term is what? 2. That is h of 1 equal to 2. And coefficient for this one is 1. Hence h of 2 equal to 1. So let us apply the DFT of h of n with the help of definition of discrete Fourier transform. Find DFT for this h of n, then indicated as h of k equal to summation over the limits n equal to 0 to m minus 1 h of n e to the power minus j 2 pi kn by m. It is the definition of DFT. Then where what is that h of n? H of n is given. Let us substitute. M value is what? 3. Contains 3 samples. M value is what? 3. So 3 minus 1, it becomes 2. H of k equal to summation over the limits n equal to 2 h of n e to the power minus j 2 pi k n. M equal to what? 3. Substitute n equal to 0. N equal to 0 means h of 0. Wherever n is there, substitute 0. N is 0. It becomes e to the power 0, 1. Hence, only we are getting h of 0. Next, go for n equal to 1. H of 1 multiplied by e to the power j 2 pi k. N is what? 1. So e to the power minus j 2 pi k by 3. Let's go for n equal to 2. H of 2 multiplied by e to the power minus j 4 pi k by 3. So h of 0, h of 1, h of 2 already we know. H of 0 is 1, this is 2, this is 1. Substitute here. Hence h of k equal to h of 0 is what? 1 plus h of 1 is what? 2. 2 into e to the power minus j 2 pi k by 3 plus h of 2 is what? 1. 1 into e to the power minus j 4 pi k by 3. The value of k, we know that the value of k varies from 0, 1, 2 up to where? M minus 1. M minus 1 means m equal to 3. 3 minus 1 means 2. So the value of k varies from k equal to 0, 1, 2. Then DFT becomes k equal to what? Substitute. This one we got. K equal to 0, that is h of 0. Substitute 1 plus 2. K equal to 0 means e to the power 0. E to the power 0 is what? 1. Hence it is 2. Next, k equal to 0. This is also 1. So 1 plus 2 plus 1 equal to 4. We calculated h of 0. Similarly, go for k equal to 1. This term is as it is 1 plus 2, and wherever k is there, substitute 1 e to the power minus j 2 pi by 3. That is e to the power minus j 2 pi by 3 plus e to the power k equal to 1. It becomes e to the power minus j 4 pi by 3. Simplifying, we are getting in the Cartesian form minus 0.5 minus j 0.866. So if you are representing in the polar form, r of e to the power j theta, that is e to the power minus j 2 pi by 3. Hence, next value k equal to last value k equal to 2. Substitute k equal to 2, 1 as it is plus 2 as it is. Here k equal to 2 means 2 pi into 2, it becomes 4 pi by 3. Next, k equal to 2, 4 pi into 2, it becomes 8 pi by 3. Simplifying this one, we are getting the answers minus 0.5 plus j 0.866. So in the other form, e to the power minus j 4 pi by 3. 4 pi by 3. Step number 2, let us find system function. Already we discussed in theoretical concept, that is h of z equal to 1 minus j to the power minus m divided by m summation k equal to 0 to m minus 1 h of k divided by 1 minus e to the power j 2 pi k by m multiplied by j to the power minus 1. We know the value of m, that is 3. Wherever m is there, substitute 3. So that is 1 minus j to the power minus 3 divided by 3 summation k equal to 0 to m minus 1 is there. M minus 1 means 2 h of k divided by 1 minus e to the power j 2 pi k by 3 multiplied by j to the power minus 1. And I'm going to split this as a two subsystem functions. This one I'm indicating as a h1 object, and this term I'm going to indicating as a h2 object. So h object is split into two parts. H1 object is indicated by 1 minus j to the power minus 3 divided by 3. and H2 object is indicated as this term. Okay, hence H2 object is this one. Further simplification, of H2 object. H2 object is what? This term. K equal to 0. H of 0 divided by 1 minus e to the power 0. That is 1 into z to the power minus 1. If k equal to 0, we got this term h of 0 divided by 1 minus z to the power minus 1. If k equal to 1, h of 1 divided by 1 minus j 2 pi by 3 into z to the power minus 1. If k equal to 2, h of 2 divided by k equal to means 2 pi into 2, 4. 4 pi by 3 multiplied by z to the power minus 1. This is what H2 object. This is what H2 object. Then we have to sketch the structure for this H1 object and H2 object. Let us sketch. First, I am going to write equations. H1 object is 1 minus z to the power minus 3 by 3. Okay. Next, H2 object equal to 4 divided by, before sketching, one more here point. We got this equation correct. H of 0. H of 0 is already calculated. See, H of 0 is already calculated. H of 0 is 4. H of 1 is e to the power minus j 2 pi by 3. H of 3 is e to the power minus j 4 pi by 3. Those values you have to substitute here. H of 0, H of 1, H of 2. So H2 object becomes H of 0 is 4. 4 divided by 1 minus j to the power minus 1 plus H of 1 is e to the power minus j 2 pi by 3 divided by, this is same, plus h of 2 is calculated, that is e to the power minus j 4 pi by 3 divided by, this denominator remains same. Now sketch this, realize this h1 object and h2 object. So for that, 1 minus j to the power minus 1, then e to the power minus j 2 pi by 3 divided by 1 minus e to the power j 2 pi by 3 z to the power minus 1 plus e to the power minus j 4 pi by 3 divided by 1 minus e to the power j 4 pi by 3 multiplied by z to the power minus 1. This one you have to realize. Okay. First, I will realize h1 object. X of n is the input. Okay. Multiplied by what? Multiplied by 1 by 3 is there. 1 by 3. Then divided by z to the power minus 3. Add with the previous operation, that is here, and it is given as a input for the second subsystem function, that is h2 object. So this one you have to realize. First term, all these values are this one, this one, this one, all are in parallel connections. So we are getting three parts here. So first part, this one time delay. Okay, one time delay, and coefficient term is what? Coefficient term is nothing is there, one is there, so it becomes 1, adding with the previous operation. Okay, this is multiplied by 4. Next, coming to this term, so observe the denominator, one time delay is there. Okay, multiplied by the coefficient term, e to the power j 2 pi by 3. Then this is multiplied by what? My e to the power minus j 2 pi by 3. Last one, one time delay and multiplied by what? E to the power j 4 pi by 3, and the entire term is multiplied by e to the power minus j 4 pi by 3. All these are added, correct? All these are added. So let us add all these values plus, then this is added plus, and the overall result is called as y of n. The overall result is called as y of n. Okay, this is about realizing the h1 object and h2 object. This is relation of what? H1 object, and this is the relation of what? H2 object, where H1 object and H2 object are in cascade connections. This is the about realizing